Hello students, I am Amit Solanki. Today I will discussing about the vector control of induction motor drives. We know that the induction motor has widely used in industrial applications. So we have to control the induction motor precisely. These are the contents of our today's lectures, and these are the reference of this lecture. First we will discussing about the introduction part of this lecture. So from a historical point of view, in the past the DC motor is widely used in area of variable speed operations due to some their good starting torque characteristic. But DC motor have certain disadvantages because of having commutator and brush. So this problem is reduced by the induction motor drives. In industry generally, three-phase induction motor is widely used due to good self-starting capability, simple and rugged structure, low cost and reliability, etc. We have the two control techniques of AC drives. One is scalar control and second one is vector control. So first, the vector control, it is a term which is used to describe a simple form of AC motor control and controlled by the adjustable magnitude of stator voltage and frequency in such a way that the air gap flux is always maintained at the desired value at the steady states. That means the scalar control, nothing is a V by F method. According to this method, we can control only speed, not torque. So for that, we are going towards the vector control methods. In vector control method, the machine current and voltage space vectors, the transformation of three-phase speed and time-dependent system into a two-coordinate time invariant system and effective PWM pattern generations. So these are the aspects of two control methods. According to previously cited, we can identify these two methods. One is scalar control and second is vector control according to comparison. So firstly, in scalar control, it is a simple form of motor control, whereas the vector control has the complex mathematical model. And scalar control have good steady state performance, but vector control have precise control of AC motors. Scalar control have poor dynamic responses, but vector control have excellent dynamic responses. The scalar control have low performance drives, whereas in vector control it have high performance drives. In scalar control there is high power dissipations, but in vector control there is low power dissipations. So according to these parameters, we can say that the vector control is widely used for the precise control of induction motor. This is the analogy with DC motor control. In this slide you can see the circuit diagram of separately excited DC motor. Both are separately excited, and the torque equation of DC motor is given that T equals to K phi Ia, where K is the constant, phi is the flux, and Ia is the armature current. And these equations we can also write in the form of T equals to K IF Ia, where IF is the field current and Ia is the armature current. And finally, this equation we can write in the form of T equals to K ID and IQ, where ID is the direct axis and IQ is the quadrature axis. According to this, the field current has same direction as field flux, and armature current has same direction as armature flux, and armature current and field flux are always perpendicular and decoupled. So according to previous slide, we can say that there is a close parallel between torque control of DC motor and vector control of an AC motor. The DC motor field flux produced by field current is orthogonal to the armature flux produced by the armature current. Because the vectors are orthogonal, so they are decoupled. That means the field current only controls the field flux and armature current only control the armature flux. So both are independently controlled. So for that, the vector control is very important method. So now we are going to main points our the what is the vector control. So according to that, the vector control is a variable frequency drive control method in which the stator current of three-phase induction motor are identified as two orthogonal components that can be visualized with the vectors. In vector control method, both flux and torque are controlled separately. So DC motor like performance of induction motor can be achieved by if the motor control is considered in the synchronously rotating reference frame where the sinusoidal variables appears as DC quantities in the steady state. According to previously slide, we have drawn here the equivalent circuit of induction motor. In this equivalent circuit, you can see that there is one current is flowing IS, that is a stator current or the starting current. In this circuit diagram, this stator current is divided in two parts after some times, and these two parts are, one is direct axis current and second one is quadrature axis current. The ID is the flux producing current, or we can say the magnetizing current, and IQ is the torque producing current. The ID having the 30% of total current and IQ having the remaining 70% of total current. And we can say that the ID having the more inductive property with respect to IQ, so we can control the IQ for controlling the torque of induction motor. So we conclude that we have less stator current and also we can control the more torque. That means we are changing the angle between ID and IQ and we can get the control of torque of induction motors. So in this diagram, the ID is the flux producing current, IQ is the torque producing current, IS is the total stator current, and D is the angle between ID and IQ. And the formula for torque is given that according to this circuit, the torque is directly proportional to ID, IQ and sin D, where D is the angle between ID and IQ. Now this is the block diagram of vector control induction motor drives. According to that, we can control the speed of induction motor drives. So according to block diagram of vector control fed by induction motor, so the vector control will transform the direct axis stator current and quadrature axis stator current fed to the inverter, and that is fed to the induction motor, so that it will decouple with this vector control method. And this is the right side, the phasor diagram is shown. According to that, IDS and IQS both are the orthogonal and with speed of omega e. Now the torque equation is given according to that, that is the K days of T, IQS and IDS, where IQS is the torque component and IDS is the field components. And we are talking about the analogues of DC motor in vector control is that in induction motor, that is IDS, it is analogous to DC motor is IF, that is a field current. As it is in case of induction motor, the IKS is quadrature axis, as it is in DC motor, that is the armature current. So these are the analogues of DC motor. Now we are going to the steps to perform the vector control. So how to vector control method is performed, and this is the algorithm. According to that, we can perform the vector control method. First, measure the motor quantities, that is phase voltage and currents, and transform them to the two-phase system alpha beta using a Clark transformations. Then calculate the rotor flux space vector, magnitude and position angle. Then transform the stator current to the dq coordinate system using the Park transformations. Now the stator current torque IQS and flux IDS producing components are separately controlled. Next, the output stator voltage space vector is calculated using the decoupling block, and inverse Park transformations transform the stator voltage space vector back from the dq coordinate system to the two-phase system fixed with the stator. And last, using the space vector modulations, the output three-phase voltage is generated. So this is the algorithm. According to that, you can perform the vector control method easily, step by step. Now this is the finally basic block diagram to implement of vector control method. So according to this block diagram, we can explain the vector control method, how to implement it actually. So in this block diagram, there is two part. In left side there is control part, and right side there is machine part, and these two parts are isolated by the inverter unity gain. So in control part, the control signals are, we can see the reference signals IDS and IQS are coming from the any controllers like microprocessor, microcontrollers or DSP, that will go to the model to the direct axis and quadrature axis stator current components. So stator space of direct axis and quadrature axis current fed to the direct axis and quadrature axis current to the three-phase current, and that is done by two-phase to three-phase transformation. And these coming signals from that transformations, that is IA, IB and IC, are three-phase current reference signal. It is fed to the inverter, which is unity gain, and that signals from inverter is goes to the three-phase to two-phase transformation model, that is done by the another transformations. Now this signals, the output of this model, that is IDS and IQS, are given to the space direct axis quadrature axis model, and with the help of reference signal cos theta and sin theta, we can again convert it into direct axis and quadrature axis synchronously rotating reference frame. Finally the signals are coming into the machine model, that is a synchronously rotating reference frame, and these are split by the omega e. So these are the complete block diagram explanation in the right side there is a transformations, and left side that is the inverse transformations. So according to that, the vector control methods are classified in two types. One is direct field oriented control, and second one is indirect field oriented current control. In direct field oriented current control, the rotation angle of the IQS vector with respect to the stator flux is being directly determined by measuring the air gap flux. And in case of indirect field oriented control, here the rotor angle is being measured indirectly, such as by measuring the slip speed. Now we can discussing about the field oriented control method, which is the one form of vector control method. The scalar control such as V by F method has its some limitations in terms of performance. So for that, the scalar control method for induction motor generate the oscillations on the produced torque. So it is not designed for precise control. Hence, to achieve the better dynamic performance, a more superior control scheme is needed for the induction motor, which is the field oriented control. The field oriented control is the first technology to control the real motor control variables of torque and flux, with decoupling between the stator current components and the torque producing component of the stator flux can be controlled separately. The field oriented control method has been developed for high performance motor applications which can operate smoothly over the wide speed range, can produce full torque at zero speed, and it is capable of quick acceleration and deceleration. So these are the advantages of field oriented control method. Now we are going towards the advantages of field oriented control. What are the advantages? Firstly, it has improved the torque responses. Then it has torque control at low frequencies and low speeds. It have dynamic speed accuracy. The field oriented control method had reduction in size of motor, cost and power consumptions. It has 4 quadrant operations and short term overload capability. So these are some advantages. According to that, we can use the field oriented control method for precise control of induction motor drives. Now the silent features of the vector control methods. The transient response will be fast because the torque control by IQS does not affect the flux. That means these are not affect to each other, they are separately controlled. Then the vector control allows for speed control in all 4 quadrants without additional of another control elements. That means we can use the vector control method in all 4 quadrant without using any additional devices. And the next advantages is that the automatically limit operations to the stable regions, and it has increased speed range. That means we are getting the wide range of speeds. And last, it have the low inertia. So these are some salient features of the vector control method in which we are using in various industrial applications. Thank you so much for watching.